Let's try to solve recurrence relations using systems of equations. The problem is, given a closed form expression, find the recurrence relation. These are the steps. Number 1, count the number of terms in the given closed form expression. Number 2, if the closed form expression does not have a constant, then add 1 to your count. Number 3, write the equations based on the number of terms in the closed form expression. Number 4, solve the systems of equations. Example number 1. D of k is equal to 5 times 2 raised to k, where k is greater than or equal to 0. Step 1, we have to count the number of terms in the given equation. And we only have 1, which is 5 times 2 raised to k. Then for step 2, we add 1 for the constant term, which is the plus 0, or in general, that would be plus c. Then we go to step 3, which is we write the two equations. And these are d of k is equal to 5 times 2 raised to k, and d of k minus 1, which is equal to 5 times 2 raised to the quantity k minus 1. So for step 4, we now solve the systems of equation. This is written as d of k minus d of k minus 1 is equal to 5 times 2 raised to k minus 5 times 2 raised to k minus 1. We proceed. So 5 times 2 raised to k minus 5 times 2 raised to k times 2 raised to negative 1. So we split 2 raised to k minus 1 into two factors. Then 5 times 2 raised to k times the quantity 1 minus 2 raised to negative 1. 5 times 2 raised to k is the common factor in the previous two terms. Proceed. 5 times 2 raised to k, that would give us 1 minus 1 half. So 5 times 2 raised to k, quantity 2 minus 1 over 2, that would give us 5 times 2 raised to k times 1 half. So if you notice, the first factor, 5 times 2 raised to k, is simply d of k. So we replace 5 times 2 raised to k in the equation with d of k over 2. So for the left-hand side, that would give us d of k minus d of k minus 1. And we multiply both sides of the equations by 2. That would give us the quantity 2 times d of k minus d of k minus 1 is equal to d of k. So we distribute 2. So that would give us that equation. The next step is we transpose d of k from the right-hand side to the left-hand side, and we get 2d of k minus d of k minus 2d of k minus 1 is equal to 0. So 2d of k minus d of k is d of k minus 2d of k minus 1 is equal to 0, where k is greater than or equal to 1. So we now have the recurrence relation for the closed form expression 5 times 2 raised to k. That's it.